Okay, so in linear programming, we're trying to maximize or minimize a function, which is a function of x and y. And this is the set of all the points, x and y, that we can plug into that function. How many points is that? All the shaded area, how many points would that include? Wait. Is it a countable number? It's infinite, right? It's an infinite number of points. So if we had to test all those values, we would never finish. But what we know is if there is a maximum or a minimum value in linear programming, it has to occur at one of the vertices. It can't happen in the middle of that area. It has to be at one of the corner points. So we don't actually have to test infinite number of points. We just, in this case, we need to test 1, 2, 3, 4. 1, 2, 3, 4. Okay, well, before we could test them, we need to know what they are. And most of the time, many of them you can tell just by looking at the graph. Like, you could tell the origin is one of them. You could tell that 1, 0 is one of them. And you can tell that 0, 2 is one of them. Right? The one that you can't tell is the intersection of the two lines, this line and this line. And you're not going to estimate it just by eyeballing the graph. You're going to need to solve a system of equations. So the system would be x plus 2y equals 4. Let me write this over here. X plus 2y equals 4 and x minus y equals 1. So as a system of equations, you could take your pick. How many different ways do we have to solve that? Substitution, elimination. How about matrices in the calculator? You could always do that. And there's going to be a quiz question that's that. So you might want to remind yourself how that happens, right? So, I mean, this one wouldn't be hard to do with elimination, right? You could like subtract one from the other. That would get rid of the x's. It would go pretty easily. Or you could solve one of these. You could solve, let's say, x equals y plus 1. Put in a y plus 1. It would go pretty easily, right? If you did it by matrices, then it would look like this. So remember, the matrix is on the x to the minus 1 button. Second, x to the minus 1. Let's see, I got to quit this pair. 1. Second, x to the minus 1. I'm going to arrow over to edit. And I'm going to edit the first matrix, right? What are the dimensions of the first matrix in this problem? 2 rows, 2 columns, 2 by 2. So, and these two have to be 2 cross 2. Okay, so it gives you 4 places to fill in the coefficients, which are 1, 2, 1, negative 1. There we go. 1, 2, 1, negative 1. Okay, now we need to fill in a matrix which represents the right-hand side, 4, 1. So go back to second, let's see, quit. Second matrix, edit, 2. Right, this matrix is 2 by 1. If you, let's say you did it 1 by 2, then when you went to look at it, it wouldn't look like it looks like there. We don't want 2 numbers side by side. We need one on top of the other. That's 2 by 1. 2 rows, 1 column. Okay, now we need the numbers 4 and 1. 4 on top of 1. So you got to get the matrices in there. And then you go to the main screen. And this is what you need to do. A to the minus 1, B. Right? It goes like this. Second matrix, and now pick 1. When it's highlighted in that first column of names, 1. And so it brings that to the screen. And then you hit x to the minus 1. so that it looks like it's being raised to the -1 power. It really means the inverse matrix. And then we go second matrix 2. So it should look like A to the -1B. And then you hit enter. And that tells you the values of X and Y. Those lines intersect at the point 2, 1. All right, this point right here, 2, 1. Okay, now that we know all the vertices, let me stop this.